Hello everyone, welcome to our channel Everyday Learning. So in today's video of probability and statistics, we are going to practice two problems from the topic binomial distribution. Now I have taken the problem from the book, so I'll mention that page number or the topic number in our description box. So let's see what do we have for this problem. In the problem, we can see that an archer hits a bullseye with a probability of 0.09 and the result of different attempts can be independent to each other. So here we have got a hint which says independent. Therefore, the distribution can be easily termed as a binomial distribution with Bernoulli trial. So we know Bernoulli trial is referred to binomial distribution because it can have only two outcomes. One is success 1 and failure 0. So let's get to the next part. It says that the archer totally takes 9 shoots. So we have to determine the following two probabilities. Now at first we shall note down the points that are stated. So we can see that the number of trials denoted by n is equals to total 9, and we have the probability of hitting bullseye. Let's consider that the probability of hitting bullseye or probability of success denoted by p is equals to 0.09. Therefore, probability of failure 1 minus p, which is also referred to as q, is equals to 1 minus 0.09. Good enough. Now we can move on to determining the probability, and we have to state that, or we can state that x follows Bernoulli trial with n trials and probability p, and we can write it as b of number of trials is 9 and probability is 0.09. Now let's get to our first problem, number A. In number A, we are asked to determine exactly the probability of two arrows that scores bullseye. Two arrows that scores bullseye. So we can say that probability of exactly two arrows hitting bullseye or exactly two success. Exactly two successes. So for probability determination of binomial distribution, we have a formula which I will write down here. The formula, I wrote the formula of determining binomial distribution probability on this side. Now let's determine the probability of exactly two successes. So here our n is 9 and success is 2, so nc2, and probability of success is 0.09 to the power x, which is 2, and then probability of failure 1 minus 0.09 to the power x is 9 minus, I'm sorry, n is 9 minus x equals to 2. So if we do the calculation, we'll end up with result 0.1507. Pretty easy. Alright, now let's move on to our next problem, number B. In number B, it is asked to find out the at least two arrows will score bullseye. At least two arrows. So at least two arrows indicate that the number of successes is minimum 2 and it can extend up to the number of total trials, which is 9. So for at least two bullseye, we can consider that minimum equals to 2, which can go up to maximum equals to 9 number of trials. So for this, what we can do is we can add up all the probabilities starting from 2 to total number of trials 9, but that would be a very lengthy process. So what we'll do in this case is probability of x greater than or equals to 2 is equal to 1 minus probability of x equals to 0 minus probability of x equals to 1. Now you have to understand that the probability of getting at least 2 or more successes can also be determined in a shortcut way by determining the probability of this portion, which is 1 minus the probability of having successes less than 2, which is there can be no bullseye indicated by probability of x equals to 0, and there can be only one bullseye subtracted from the total probability 1. So we'll have here 1 minus, it will be 9C0, 0.09 to the power 0, and 1 minus 0.09 to the power 9 minus 0 minus 9C1, 0.09 to the power 1, and 1 minus 0.09 to the power 9 minus 1. Now if we do the calculation, we'll get 1 minus, for this one we have 0.4279, and for this one we have minus 0.3809. So after doing the calculation, we get 0.1912. That is our final result. And lastly, we're asked to find out the expected number of bullseye. So we know expectation for binomial is e of x equal to number of trials into the probability of success. So we have 9 trials in total into the probability of success is 0.09. So after calculating, we get 0.81, which is the expectation of bullseye, which is the success for this problem in here. Now let us move on to our next problem, in which it says that a company receives 60% of its orders over the internet. With a collection of total 18 independently placed orders, what is the probability that between 8 and 10 orders are received over the internet? This is the first one, and the second one is no more than 4 of the orders are received over the internet. Now here it is also classified using Bernoulli trial, or can be determined using binomial distribution, because as we can see here that over the internet, so the success is when order is placed over the internet, and the failure is when not over internet the company gets the order for any product. So we can see that the probability of success or getting order over the internet is 60%. So we can rewrite it using 0.60, and the total number of independent orders, number of trials, it can be said is equals to 18. So it follows binomial distribution with number of trials 18 and probability of success 0.60. Now it's pretty easy. Let's move on to number A. In number A, in number A, we are asked to find out between 8 to 10 orders. So for between 8 to 10 orders, we know we have x equals to 8 plus x equals to 9 plus x equals to 10, because it's between 8 to 10 orders. Now for 8 to 10 orders, what we'll have to do is, for 8, 18C8, 0.60 to the power 8 into 1 minus 0.60 to the power 18 minus 8. This is for probability of x equals to 8, plus we'll have to do the same for 9 and 10, which is 18C9 0.60 to the power 9 into 1 minus 0.60 to the power 18 minus 9, plus we have 18C10, 0.60 to the power 10 into 1 minus 0.60 to the power 18 minus 10. So if we add up all this together, it can be done easily using the calculator. We'll get 0.0771 plus 0.1284 plus 0.1734. Total equals to 0.3789. So this is the probability of getting orders between 8 to 10 through the internet. Now let us move on to number B. In number B, it is asked that no more than 4 of the orders are received over the internet. No more than 4. That means the number of success will be less than or equals to 4, as it says that no more than 4 orders. That is, the number of orders received through internet is less than or equals to 4. So now what we can do is probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2, probability of x equals to 3, and probability of x equals to 4. We'll get the result. Now we'll have to apply the same formula like the previous one. I'll show for probability of x equals to 0, 18C0, 0.60 to the power 0, and 1 minus 0.60 to the power 18 minus 0. In this way, the rest of the formulas need to be rewritten, and finally, after summing up all of them, the result we'll get is 0.0013. Now it will give an exponential result which needs to be rewritten using this value. So we can understand that the number of successes being less than or equals to 4 is only 0.0013. So in this way, several problems related to binomial distribution referred by Bernoulli trial can easily be solved. I hope you got pretty clear idea of using the formulas and how to solve such problems. If you have any confusion or queries, feel free to write down below, and thank you for watching this video.